Now we know the power rule for the derivative of x raised to any rational number. We know that the derivative with respect to x of x to the nth power is equal to n times x to the n minus 1. And as it turns out, we can actually extend this to allow n to be any real number. So if you let n be any number and let u be a differentiable function of x, the derivative with respect to x of x to the n is n times x to the n minus 1. And the derivative of u to the n is n times u to the n minus 1 times u prime. So some of these can look kind of nasty, but I want to show you four very similar looking integrals that have four very different approaches. So you can see that all four of these look very similar, but they're going to be vastly different in how you would want to work them. So this one right here is e to the e. Now e is a number, so this is just a derivative of a constant. So this one's going to be 0. And you're done. This is the derivative of e to the x, so this is e raised to the x power. So we know that e is its own derivative, so this is e to the x. This one is the derivative of x to the e. So in this case, n is equal to e. Even though it's irrational, we can still use this power rule, so this will be e times x to the e minus 1 power. And that would be your answer there. And you can't simplify that at all. That's in lowest terms. Now this one is x to the x power, so there is a variable in both the base and the power. Now this is where that logarithmic differentiation that I mentioned earlier comes into play. This is not something that I expect you to be able to do at this point, but I do want you to be aware that it exists. So the way I would work something like this, I would start off by letting y be equal to x to the x power. And I'm trying to find y prime, which is the derivative with respect to x of x to the x. So the other way I could look at this is that this is dy over dx. So I'm going to start off with y equals x to the x power, and I'm going to take the natural log of both sides. Now the reason why I'm taking the natural log of both sides is that the natural log is a rock star at getting variables out of exponents, and we have a variable and an exponent. So I'm going to use the power property of logarithms to bring that out front. So I would have the natural log of y equals x times the natural log of x. And then I'm going to take the derivative of both sides. So this will be the derivative with respect to x of natural log of y equals the derivative with respect to x of x times the natural log of x. Now on this side, notice that my x and my y don't match. So this is going to be 1 over y, but then I have to multiply it by y prime or dy over dx. And on this side, I'm going to have to use the product rule, because I have x times the natural log of x. So f would be x, which means f prime would be 1, and g would be the natural log of x, so g prime would be 1 over x. So on this side, I'm going to have f g prime plus g f prime. So I have 1 over y times dy over dx equals 1 plus natural log of x, and I want dy over dx. That's my goal. So in order to get that, I'm going to multiply both sides by y. So I have dy over dx equals y times 1 plus natural log of x. And we're not quite done yet because we actually know a formula for y. Y is equal to x to the x power. So this will be x to the x power times 1 plus natural log of x. And that is my final answer. So that is logarithmic differentiation. Again, not something that I expect you to be able to do for this course, but it is something that you should be aware of.